So these are the notes for indicator 6. And if you're at home, take a minute, pause the video. And at the very beginning of your notes for indicator 6, I want you to write these notes down. So if the directions or the instructions of your homework say write a rule, write an equation, write a function, or if it says describe the relationship between X and Y, all 4 of these, they always are going to mean write an equation in Y equals mx plus b. And of course, we know I wrote it at the bottom, but I didn't write it at the top. You can't write an equation without a slope. So in all of these instances, you're going to find the slope, and then you're going to write an equation in Y equals mx plus b. And this is why I lump 5 and 6 together, because we've been doing this, right? We've been given 2 points. We find a slope. We use one of those points, and whatever method you use, whether it's find the b or point slope, you end up getting an equation in Y equals mx plus b. Okay. So let's look at what it looks like when it's in a table. So we'll do this first example here. And a table is it's called a relation or a set of points. And it's just a different way to deliver a bunch of ordered pairs, right? So instead of, and I'll write it here, but what this right here is the ordered pair -3, 5. It's the X and Y that go together. It's just in a table form rather than writing it like an ordered pair. This is the point -4, 7 on all the way down, right? Each one of these just makes up an ordered pair. The top is always your X, the bottom is always your Y. And notice it says Y and then it says or f of X. I want to get you guys used to seeing f of X. If you see it, it's just a fancy Y. Okay, it just means it's a function that you can plug X's in and get a Y value out of it. Okay, that's all it is. So I just kind of want to get you used to seeing f of X. So the directions for that first example say write an equation. Well, we know that whether it says write an equation, if you notice number 2, it says write a rule. It doesn't matter. Our goal is always Y equals mx plus b, right? That's my end goal here. And I know to do that, I need an M and I need a B, okay? Same as indicator 5. The only difference is that when you have it in table form, it makes it a little bit easier to see the relationship between X and Y. So you can find your slope one of 2 ways. You can do it the way we've been doing it, right? So we can do M equals, and I've got 5 points here to choose from. Does not matter which of the 5 you pick any 2, okay? I'll pick the 2 I already wrote, just because it's easier to see it that way. So this would be my X1, my Y1, my X2, and my Y2. I'm used to seeing that. And I would plug it into my slope formula. So I would have 7 minus 5 over -4 minus a -3 would go plus. So 7 minus 5 is 2. And -4 plus 3 is -1. So my slope in the end, when I reduce it, which I'm going to write it back over here on the left, would be a -2. I'm filling in my M and my B here. Now, when it's in table form, first of all, slope is change in Y's over change in X's. Do you guys remember that from indicator 5- or 5-1, right? The slope is your change in Y's over your change in X's. Or, kind of like you saw it written at the very beginning of the notes, the relationship between how X or how Y changes every time X changes, right? And in this case, every time Y goes up 2, X goes up 1. Y goes up 2, X goes up 1. It goes on forever and ever and ever as an endless up 1 over 2, or yeah, this is negative, sorry, down 2 over 1, down 2 over 1, down 2 over 1, okay? If you look at your table, and I'm going to look at my Y's first, and the real danger here is tables X's are on top, slope Y's are on top. So you really have to be careful to keep your Y's on top. But if we look at our Y's, right, I'm going to look at this right here, our Y's. What happens to my Y every time I move, like I'm reading left to right? What happens to my Y? 5 to 7, it does what? Adds 2. Okay. And then Logan again, 7 to 9. What's that do? plus 2. Notice a pattern. Every time I look from left to right, every point I go, I increase by 2, right? Or my y's change by a positive 2, which over here, when I found my slope the old-fashioned way of using our formula, is that not what happened? My y went positive 2 every time. Now, look at your x, right? And again, you got to be careful because x's are on top in tables. But what happens to my x with every move? -3 to -4 is a, yeah, it's a -1 move, right? I go -1. Every move I make, I go -1, which means my change in x's is a -1. Well, again, looking at my slope when I found it using my formula, isn't that the change I saw in my x's? So my slope is the change in y, which is increasing by 2, over the change in x, which in this case is decreasing every time by 1. So my slope is a -2. If I were to ask you to name the next ordered pair that went right here, somebody tell me what I'd write. Kinsley? Yeah, I would change -1 again in my x, and my y's would change positive 2, which would be 15. So I could write as many ordered pairs for this line as I wanted to, because it's always going to be that same change in x and same change in y. Okay, good with that. And I'll show you where it'll kind of come in play in a second, where it's really going to make these really easy, because with some of these, you're going to have to do like zero math or almost zero math. Okay, so you can do slope the old-fashioned way. You can use the formula, plug it in, or you can just look at your change in y's, look at your change in x's, and build your own slope that way. Just make sure your y's are on top in your slope. All right, so I have my m. I have a couple different ways I can find my equation now. I'm going to go ahead and do point slope form. I've got 5 points to choose from. It doesn't matter which one I choose, because I'm going to get the exact same answer either way. All right. So if I choose to do it, I'm going to erase all of this because I'm actually going to do it both ways here. If I choose to do it in point slope form, I'll pick a point. I'll just pick this one right here. So I'm going to go y. Now my y here is the 11. Be mindful which one's your y and which one's your x. Y minus 11 equals my slope, which is -2. And then x minus a -6 goes plus. And when I distribute, I get y minus 11 equals -2x. -2 times +6 is -12. And then I add an 11 and add an 11. And I end up with y equals -2x minus 1. So there is my equation for this set of points, or this relation. This is an equation that I could use. This is my slope-intercept equation that represents the line. If you were to graph all of these points, it would graph this line. Yes?
Okay, I did like unit in my equals mx plus b, or just slow it down. I did it that way.
I'm going to do it both ways. Yep. The other way to do it is, if you want to find your b, you can start with y equals mx plus b, and you can pick a point, any point, right? Let's pick this one. And I can plug it in with my slope that I've already found. So in this case, my y value is a 5, equals the m I found times the x that I chose to use, which is -3, plus b. And when I -2 times -3 is +6, plus b. And when I subtract 1 from both sides, I end up getting that b equals -1. So now I have my m and I have my b, and I can go out and I can write y equals -2x minus 1. Notice I got the exact same thing. Okay, both ways are valid ways, and you noticed I purposely used different points. Use any point in your table and it's going to work. Okay. Now, I'm going to do this next example without using the slope formula, by just looking for the pattern in our change in y's over the pattern in our change in x's. So instead of doing the y2 minus 1, which is really what we're doing, we're just kind of shortcutting it a little bit. I'm going to find my slope here. So remember, y's on top. So do your y's first, right? Y's on top. Here's my y's. I go from 3 to 0. What kind of a move is that? 3 to 0. Yes. Yeah, it's a -3 move. And if you want to just test your pattern, 0 to -3, -3 again. So my top, my change in Y is -3 over my change in X. So now I look at my X and I went from, sometimes if you're in the negative, sometimes it can be harder to see. So if you want to jump forward and just say, what am I doing going from 0 to 1? What is it? It's +1, right? It's easier to see sometimes when you're in the positive. But still, -2 to -1 is still a +1 move. It's not like it changes it, just it's easier to see. So my overall slope when I'm reduced here is -3. Now this one is kind of nice. I'm going to erase my little slope arrows here. What is unique about intercepts? If you guys remember, think back to 5-1.
They all, so say the X-intercept would have X, but Y would be 0, Y would have 0, only 1.
So if I need the Y-intercept, if I have a point like this right here, say, where the X is 0, what does that automatically make this -3? Yeah.
The Y.
Yeah, that's your Y-intercept. You don't even have to plug in and find your B. It's given to you. This is just one of those nice little gimmies. Take it as a freebie and run with it, okay? Find your slope, however you want to find your slope. Doesn't matter to me how you do it, whether you do it by counting or you do it by using the old formula, okay? Once you find your slope, do a quick glance and see if you're given your Y-intercept. If you are, great. It's a gimme, it's a freebie, take it. If your X is 0, that is your Y-intercept.
Interruption. Timothy Bishop, report back to the cafeteria. Timothy Bishop, report back to the cafeteria immediately.
Notice that the Y being 0 doesn't help you at all. Okay, that's nothing, at least not in Y = mx + b. It's a point on the line, but it doesn't do anything to help you. The only time it's a freebie and it's a give me is when your X is 0, because that makes that your Y-intercept because of that opposite rule. Now, without any math, without really doing much math at all, we've got our M and we've got our B. So we can write our equation. Notice the difference in work, right? Between the first example and the second example. It's a lot less work. Sometimes in a table, it's easier to see the patterns than it is in just well, with 2 points, you can't really see a pattern. But when you have multiple points, especially if they're in a table, you can see a pattern. It's kind of nice. All right, with this one, you don't have to write this one down. We're just going to talk through it. You don't have to have 3 examples in your notes. But remember, my slope is my change in Y's first. What's my Y's do? Anybody? +10, okay? What do my X's do? +2. Reduce it, my M is 5. Now notice here, I'm not given the gimme, the freebie, right? I'm not given the X of 0. So I do have to do it the old fashioned way. I don't care if you pick a point or if you find your B, it doesn't matter. I'll take 13 and 30. So if I have Y - 30 equals 5 times X - 13, Y - 30 equals 5X. Is it 65? I think it's 65. 5 times -13 is -65. Add 30 and add 30, and I get Y equals 5X. -65 plus 30 is -35. Okay? We good there? Did I miss that? Seems like a really big intercept, but. Oh no, it's good. All right. Now, again, on your homework, you're going to see something like this. Describe the relationship between the X and the Y values. Okay. In indicator 6, it doesn't matter what the directions tell you. They all mean the same thing. Y equals mx plus b. Okay. Pick 2 points, find your M, and then whatever method you choose, whether it's point slope or slope intercept, plug in, find your B, and then write your final answer in Y equals mx plus b. I don't feel like we need to do more examples because I kind of feel like at this point it's overkill. You guys have been doing this now for a week. So unless you have a specific question, you can come up and ask me individually. It's no different when it's written like this. It would be no different than in last week's assignment when you were just given 2 points. Okay, just because you're given more doesn't change anything. Pick whatever 2 points you want to pick and run with it. Okay. All right. For those of you at home, go ahead and click on the load button after you've taken notes and email me if you have any questions. And then tomorrow's assignment will be the Indicator 5 review. And then on Thursday, we'll be taking the Indicator 5 quiz. Oh, I'm sorry, Indicator 5 and Indicator 6 quiz. We're mushing them together into one quiz. Let me know if you have any questions.